All right. GM everyone. So, like I said the other time, we will be continuing from where we stopped last week. We'll be continuing from where we stopped last week. And we started talking about, sorry, excuse me. We started talking about blockchain basics, where we looked at, okay, who can tell us what we looked at so that to be a little bit more interactive? If you're not in a noisy place, you can talk. But if you're in a noisy place, you can use the community chat. So what did we look at last week? Let's quickly do a recap so that we can get into our yarn for today. Samuel, Lawal, Mariesta, Danny, what did we look at last week?
All right, you can hear me.
Yeah.
Last week we talked about blockchain, how it's a decentralized distributed ledger that stores data and transactions across multiple computers. So we then looked at the components of blockchain, which are the blocks, the hash, nodes, consensus mechanism. Then you pointed out two consensus mechanism, which is proof of work and proof of stake. Then
Okay.
you told us how blockchain works. You put it into 4 steps. The first step you mentioned was transaction initiation. The second step was
Okay.
validation. The third step was block formation. And the fourth step was adding to the chain. Yeah.
Okay.
Should I begin to explain all of them again?
Oh no no.
I just
Oh no no no.
I
You've
just need
done just you've done justice.
uh,
All right. So it's not just Danny that is on this call. Please, if Samuel, Lawal, Mariesta, please can you react in the community if you are in a noisy place that you can't talk? I want everywhere to be quite lively and engaging. Please, 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 let's react in the community. I don't know if you guys can hear me. All right. Okay, perfect, great. So today basically we'll be talking about, like I said today before I start talking about different kinds of blockchain, like some of the things we were not able to look at last week. I'll be making some clarification on evolution of web. So talking about evolution of web, so the evolution of web is categorized into web 1, web 2, and web 3, all right? Evolution of web is categorized into web 1, web 2, and web 3. And we'll be talking about them, what web 1 is, what web 2 is, and what web 3 is. All right, so looking at web 1, so web 1 can also be called static web, and this web was prominent in between 1990 and 2000. All right, so this was like the order of the day between 1990 and 2000. So the early internet is known as the web 1. So that was what the internet was before. So it was just static HTML pages. The web 1 is still in usage today. So things like when you visit something like info websites, all right, if you've come across meme projects or meme tokens, the info websites, you see that these webs it just gives you a vibe of what Web 1.0 is. It's just read only. You are just there to get information about the company. So you can't interact, you can't give your 2 cents, you can't contribute, you can't engage. So it's just to read and go. So this is just what Web 1 was all about. So it was static. So some of the characteristics of this Web 1 is that it was static website. It had limited interaction, like I said. You can't interact, you can't ask questions, you can't engage. It's just read and you go. It was content. The content was produced by few and consumed by many. So it was just like I said, it's people produce this content. It's just like the way you read a newspaper. So when you grab a newspaper to read, they are not asking for your opinion. All you just do is read the information on the newspaper, and they tell you what they want to tell you, and they don't want the feedback from you. So you just tell them what you want to say and you move ahead. All right. So this is just what Web1 was like. It was just a read only. So some of these things, like I said, is HTML website, like info websites now. All right. Like info websites where you get information. I use meme projects because it's mostly meme projects that have these info websites. So I used meme projects as a reference. When you check out the meme project, you see that they use info websites. You just read up information. Maybe you're checking what are you checking now? Maybe you're checking the contract address, what is the project about, the ticker, and the rest of them. So in HTML website, then graphics, all right, maybe all these static graphics. It's just like someone sends you a meme. So the person just sends you an image, all right? So in that image now in itself, you can't respond, all right? But in the platform that image was sent, you can respond. But that image in itself, it doesn't give you an opportunity to interact. Or the person just wanted to pass you across that information that image is providing. Please, if you can still hear me, can you notify in the chat? If you can still hear me. If you can still hear me, can you notify in the chat? Or can you unmute your mic and speak? Can someone hear me?
Yes, we can see you.
Yes, we are with you, sir.
Oh, okay, great. So this is what Web1 is all about. So talking about Web2, Web2 took it a step further, and Web2 brought in the interaction into the evolution of web. So from the years 2000, till presently, we still use Web2 based application. So this Web2 now marks the shift from user-generated content, so a shift to user-generated content. So you now have social interactions. You now have where you can, give your mind, so you're not just reading what other people wrote. You can upload, all right? You can give informations to, you can share informations to. Talking about this thing now, you are seeing things like Google, Facebook, Amazon, some of these platforms, Meta, and the rest of them. So some of these platforms, you can share these informations on some of these platforms. So this is why, like Telegram now is a Web2 application because you can interact. Now we are having a class. It's an interaction. I talk, you can respond. Maybe if I give you an opportunity to speak right now, you can share your mind. You can say what you have to say, that kind of thing. So it actually builds the interaction. So that is what Web2 was all about. This is how video calls was introduced, Google Meet was introduced, different human person-to-person interaction thing was introduced. But this particular Web2 has this limitation. So as the Web1 has its own limitation, which was, it was just a read-only. You just get information. So you just can only just give out information. You just can only read information. So you can't contribute. You can't share your point of view and everything. So that was one of the limitations of Web1. It was helpful at that point. It did what it should do, but the web needed more interaction. It wasn't just a place for information. It was taken to a new level of interaction. This is what Web2 did. Please hope we are following me. Please, if you are following, I would like you to be, dropping nice emoji in the chat. Thank you. So this is what, like I said, Web2 now took it to the interaction stage where I mentioned some of these platforms. I already mentioned Facebook, even X, Reddit, the rest of them. These platforms are also good. So one of the challenges of this Web2 platform is that they use centralized data control. All right. So centralized data control, and which leads to privacy and security issues. Okay. if it's this Web2 application, because the data are stored in a centralized way, it leads to privacy issues, security issues, because you are not totally in control of the information you put out. Like now, if you upload a picture to Facebook, someone can download that picture without your permission. All right? Someone can download that picture without your permission. All right? So this is part of the concerns, and Facebook has access to what's your data. And I think I was saying something. I had a time with the ValueCorp, the ValueCorp community. Was it sometime last week? And I was saying something there, and that thing I was saying was, when you upload, this is why you have to be careful when you put out information on social media. These are why you have to be careful when you put out information on social media, because when you make a post and delete it, okay, there was this thing that happened when I was younger. When you were younger and maybe you just have a new Facebook account, you'll be tempted to post a lot of things. All right. So there was my Instagram account that I just recovered recently, and I saw things I posted there. I wasn't proud of myself. I wasn't proud of myself a bit. So, so my Facebook account now, I've had my Facebook account since maybe let me say 2018 or so. Yeah, because when I opened when I was in secondary school, I lost it to scammers. So I opened a new one in 2018. I was already in the university then. So that one I opened in 2018. There were some informations there. Okay, I think the one I even opened in 2016. Then I was after secondary school, pictures I took, just like that. Then there's this craze of you want to upload, you want to, post and stuff like that. So, and there was a time I deleted those things from my Facebook. But all of a sudden, someone can just randomly hit me up and send me that picture. And I know that this picture, I deleted this picture. So how is that person having access to that picture? So possibly when I uploaded that picture, those people had it. So even when I deleted it, they still have it. All right. So even all these leaked videos, maybe someone mistakenly post something on Snap, before you delete it, 5, 6 persons don't see them, don't screen record them, don't share you get. So, and if there's one of the in the technology market, if there's one thing that is one of the biggest things there, is that data is like the oil well of the technology market. Data is one of the biggest things that have been sold in technology market. That is where some of these companies make their money from. That is why and they use algorithm. That's why maybe you can make a Google search. All right. Next time you're going up to Facebook, you are seeing stuff related to that thing you search on Google. You go to Instagram, you are seeing related stuff. All right. You are seeing ads pulling up around. Maybe you go to YouTube too. You are seeing they are giving you feeds related to those things you've searched. So what are they trying to do? These guys share data. So once they're able to notice, oh, maybe this is something you're likely interested in. That's why if you watch TikTok now and you're scrolling on TikTok, you're watching a TikTok video and you spend so much time in one video. Maybe you watch the video completely. Videos you'll be seeing after that are videos related to that one you watched before. All right. So if you watch, maybe you like all these history-related videos where they tell you what happened during the Biafran War, what happened in Nigeria in the 1990s, in the early 18s, and stuff like that, the early 19s and stuff like that. When you keep on going, you see things related. So all I'm just trying to make sure is that you understand the implication of putting stuff out there, even with your mobile phone, your laptop. All right, these companies still have access to this information. It's just that that's why if you pay attention to world leaders, all right, world leaders, they don't really use all these things. Some of them use burner phones. I think the president of Russia, I think he was the one, or there's this president, he still uses land phone. He doesn't, it's not doing anything on social media. He doesn't use like this whole, the whole Samsung, the whole iPhone 16, And some of their own, even if they use like iPhone 15s, their phones are quite secure. They don't just their own is customized, double security. All right. So it's ahead. I think that should be put in. All right, that should be put in. So you get, so this is like why you should, things that concern people around. All these things I'm just telling you is to explain things that concern people around the whole Web2 thing, being able to not share data. So fast forwarding to 2010, all right, where the whole concept of Web3, started from 2009, when Bitcoin was talked about, but down to 2010, where it was fully, emerged, it became quite popular. So from 2010 now, excuse me, we've been looking at, the whole Web3 thing. So Web3 was just focused on addressing those issues that Web2 had, those limitations that Web2 had. So Web3 is just like an evolution of web or technology where you have decentralization. All right. So in Web2 you use centralized systems to store data, but in Web3 you use decentralized system. If we talked about these things last week, all right. So in Web2 you use the centralized systems. Web3 solve that problem by coming up with a decentralized system. All right. So I don't know. Are you guys following me? Please, if you are following me, drop an emoji or something in the call chat. I really want everyone to be inclined. All right. Okay, fine. That's great. So okay, great. So I think, well, if you are still joining, you can still share the call link for other people to get on the call. All right, for other people to get on the call and learn too. So yeah, that's it. So like I said, the Web3 solved this problem. All right, the Web3 solved this problem by introducing one, decentralization. So we now have decentralized technology through blockchain. All right. So now you now have data ownership. So in the Web3 space, someone can't have hold on your information without your knowing. All right. Someone can share your info. Someone can download your info and have your stuff without your permission. All right. So this is some of the things the Web3 came to solve. That's why when you visit maybe Web3 social applications, it's quite different. It's quite, unique, and is different from the regular thing we have. Okay. So talking about that, some of the characteristics of this Web3 is decentralized application, like I mentioned, social apps, Web3 social apps that fall under decentralized application. The blockchain technology, P2P, where you can interact person to person without an intermediary or third party. All right. Data ownership. So data ownership now in the Web3 space now. Unlike the Web2, this data ownership, this data is controlled by those platforms. Now, the Meta company has access to your Instagram, your WhatsApp, every message you sent on Instagram, every like, every activity you've done on Instagram from the first day you open your account, Meta has access to it. So that goes to WhatsApp, even your view ones and the rest of them. All right, they have access to these things. Down to your Facebook, everything you've ever posted right from when you open an account in that platform, they have all access to it. So, but in the Web3, this data is not owned by those platforms. Rather, it is controlled by the user. All right, so it is user-owned data. So in the Web3 space, these data are user-owned. So even when you have a choice to make your information public or private, or before someone can access your information, they have to, consult you. You have to be the one to be like, okay, you can use this, you can make use of this information. I hope we are following. If you are following me, please, I would like you to engage. If you're following me, I would like you to engage. All right. All right. All right. That's good. That's good. So, okay, that's good. So, yeah. So I said I was going to talk about, okay, I said I was going to talk about this evolution of web to clear a lot of things from, last week. All right, to clear a lot of things from last week. So, yeah, so from what we talked about last week, we talked about, before we started, we looked into, how um, how transactions are being carried out on the blockchain, from the transaction initiation, the validation, the block formation, and the addition or adding the transaction to the blockchain. All right. So we'll be looking at types of blockchain. All right. So I know this is like the 100th time. That's an exaggeration, though. It's like we've talked about the types of blockchain a lot. So who can just like maybe try to list the different types of blockchain? We can quickly do that. These different types of blockchain.
Yeah. So the things only two I can remember, private and public blockchain. Can't remember the other one. Abi?
Okay. Yeah, they are part of it. Who else? Who else can give it a try? Who can list the four? They don't even know whether I'll give you a gift. Nobody wants to even attempt. Yeah. I feel like feeling generous tonight.
All right.
No one wants to list the four.
I want to list.
You don't go browser. You don't go browser. Why at least?
Private, public, hybrid, and consortium blockchain.
You don't go browser. Thank you. All right. He's actually correct. The private blockchain, the public
Yes.
blockchain, the consortium,
And I hope you're still feeling generous.
No, after going
And
to
I
Google,
got two correct.
I said before, I'm gonna go to Google and collect your reward. Private blockchain. Yes, we'll get to that. So, talking about types of blockchain here. So, we have the private blockchain, the public blockchain, the consortium, and the hybrid blockchain. So, these are like the four major types of blockchain. So, public blockchain simply refers to a kind of blockchain that is open to everyone to participate. And this is where majority of cryptocurrencies fall under, right? Because the blockchain is public, that is why you can track transactions. That is why you can be able to, see what's going on in the blockchain. Okay, I think I was on call with Steven today, and we are looking at there's this thing you call this Web3 platform that is called Portfolio Manager. You can look at it, the bank and Zapper, Zapper, and DBank, DEBANK, these platforms. So what does this platform do? This platform gives you information of what is going on in the blockchain. So you can paste a wallet address there and you see what is going on in that wallet address. You can paste a token address, that is a contract address, and see what is going on in that contract address. You're seeing people that are buying, people that are selling, depending on the blockchain. I think those DBank and Zapify, they are what do you call it? They are multi-chain, but even though it's mostly focused on what do you call it? EVM. So they are EVM multi-chain. So all EVM chains you can access it. So once you paste an address that is OX kini, they will give you information whether a project that launches on Ethereum, BSC, Polygon, and layer 2s, and all of that. So that is what some of this platform does. So this is to show you that I'm just trying to explain what public blockchain is. If you remember, sometimes when we had a class, I told you guys that, oh, you can go. I think I dropped my wallet address and say, okay, this is my BSC wallet address. I'll be making transaction with this wallet. So you can go to BSC Scan and check out things I've done with that wallet. All right. You can go to BSC Scan and check out transaction I've done there, what my portfolio is like. Okay, this is the my current holdings, project I'm holding, the currencies I'm holding, and the rest of them. All right. Stuff like that. All right. So not just I did the other time. So this is to show you that the cryptocurrency operates in the public blockchain. So public blockchain is something that can be accessible to everything. Like you have the Bitcoin, Ethereum, BSC. These are public blockchains. Solana, these are public blockchain because you can be able to monitor what's going on. This is how sometimes how scammers are being caught. That's why as we keep on going, people who scam via cryptocurrency, some of them, why some of them don't escape, because this transaction can be tracked. And sometimes when this transaction is tracked to a centralized exchange, all right, that is because to operate a centralized exchange now, you have to do some level of verification, maybe your face verification, your KINI, your ID. So with that now, when someone reports that, oh, I've been scammed, then the person shows proof of them being scammed, all right? So with this thing now, they can say, okay, which wallet address did you transfer the money? So they can come down and be tracing, okay, money moved from here to here, money moved from here to here. And you can't sell this cryptocurrency, or most people sell their cryptocurrency through centralized exchange. So maybe you now want to do P2P, then you now transfer to Binance. That is how some of these people are being caught and everything. All right. So this is just something about the public blockchain. Then talking about private blockchain, it's just basically the opposite of the public blockchain, which is some of these things. You have restricted access, and they are mostly used by organizations. All right, it's not what everybody can access. It's not open to the public. It's just secluded by an autonomous organization. So, like now, the way we are at Cascade, we can build a blockchain that only members can interact with. So once you come into Cascade, we can give you an identity card. So it's with that identity card, you can be able to interact within this Cascade blockchain. So this is how private blockchain works, but it is not really, it's not very renowned, because most time it doesn't have so much use case like public blockchain. So that is why it's not really popular. They're talking about the hybrid. Hybrid is just like a mixture of public blockchain and private blockchain. And funny enough, some cryptocurrencies, fall under this hybrid blockchain. And some of those cryptocurrencies, you are looking at who has heard of Monera. Monera is one cryptocurrency. I think there was a movie I was seeing one time, and Monera is one cryptocurrency that scammers, or not just scammers now, even people who want to take ransom. I think this movie I was watching, someone's child was kidnapped. All right, someone's child was kidnapped. Sorry, Danny, what did you say?
Just saying,
So
you say a cryptocurrency that cannot be tracked, so that's why they
yeah,
use it for stuff.
yeah, exactly. So this Monera, it cannot be tracked, or it's difficult to track. Let me just put it that way. So the way the blockchain works, you can't really see transactions. It's not really totally open. All right, you can make transactions, but you cannot really trace transactions. So this is how it falls under the hybrid kind of blockchain. So like I was saying, there was this movie I saw, and someone's child was kidnapped, a government official, his child was kidnapped, like this wealthy guy, his child was kidnapped. So, and the only way, the way they asked for ransom was through Monera. Like, I think Monera, the ticker is XMR or so, or XRM. I can't really remember again. I think it's XMR or so. So Monera, so it was through Monera. And why they specifically use that Monera is because it is almost impossible to trace the transaction. So once you send in money to a wallet address, you can't really monitor, okay, what that wallet address you send that money to is doing. All right. So you can't really monitor what that wallet address is doing. You can't really see when that wallet address sends out money. So all you can just see, oh, money moves from here to here. Like this person can, in fact, the person can even tell you that, oh, this is I think the person can just tell you money move from here to here. This is how you transfer the money. So I'm not even sure if Monera has the blockchain explorer where you can track, okay, transaction movement and everything. So a project like that or a blockchain like that is an example of a hybrid. So it's partly private, it's partly public. So they select the kind of data that you can share or the kind of information that you can access on the blockchain. Am I communicating? Am I following, guys? Please, if you are learning something, I would like you to ginger the group chat. All right, cool. So so I mentioned public already. I've mentioned private. I've mentioned the hybrid. So we'll be looking at the constituent blockchain. So this constituent blockchain is a kind of blockchain that is controlled by a group of organizations. All right. So it's not just really like a single entity. It's like it's not just controlled by like a particular body. So it's just like a group of people coming together to use. So it's a little bit advanced from a private blockchain. So it creates a balance between decentralization and efficiency. All right. So it's close to a decentralized block. It's how do I explain it now? It is not fully decentralized, but it's partly decentralized and partly controlled. All right. So it's controlled by different bodies. So one particular entity doesn't have a whole say about this blockchain. So it is when maybe the 3 or 4 bodies can come together and agree on something before something is being carried out or before something is being done on the blockchain. So this is how constituent blockchain works, all right? So these are not very popular blockchains. Why most times we hear about blockchains, the ones you tend to hear is, in fact, the most popular of them is the public blockchain because this is where the currency falls under decentralized applications, and many things like many activities that go on the blockchain happen, or many blockchain networks built on the public part of the blockchain or on the public blockchain. All right. So that is that on types of blockchain. So one other or two other things we'll be looking at is what are consensus mechanisms. All right, consensus mechanism. So consensus mechanism, I talked about consensus mechanism last week, and I was talking about it again. So consensus mechanism is simply the process of, when we're explaining transaction initiation, transaction validation, transaction addition, and everything. This is just simply consensus mechanism. All right. This is just those 4 steps. The general word for it is consensus mechanism. So what happens between a sender, a crypto sender, and a crypto receiver? What's that process? It's called the process of funds going from me to maybe alpha on the core is consensus mechanism. So these consensus mechanisms have different kinds. You have the proof of work and you have the proof of stake. But these are like the 2 major kinds of consensus mechanism. There are other kinds of consensus mechanism. You have the delegate proof of stake, proof of autonomy, proof of there is a lot. I think there was a time we were looking at consensus mechanisms. I think we had about 8 or 9 of them. And as new projects are coming out, they are coming up with their unique kind of consensus mechanism. So while we have proof of work and proof of stake as the two major kinds of consensus mechanisms, because Bitcoin uses proof of work, which is like the number one cryptocurrency in the world. Then Ethereum uses proof of stake, which is the number two cryptocurrency in the world, or we call it king of alts. So Ethereum is the king of altcoin, and Bitcoin is the king of cryptocurrencies. All right. So this is it. All right. So this proof of work, I will just be explaining what proof of work is, even though I've explained it last week. So, but I'll just be, go over it again, because why sometimes this thing coming repetitively is you can't really separate some of these things from one another. That's why we can be discussing this topic and this thing comes up again, and we can be talking about another topic and some of these things comes up again. All right. So proof of work is just simply solving mathematical puzzles to validate a transaction and create new blocks. This is what proof of work simply means. So when a transaction is passed into the blockchain, or when a transaction is initiated into the blockchain, so for these transactions to be validated, the miner, now because we're using proof of work, so we'll call them miners. The miners, or the node, because there are different kinds of nodes, and some part of nodes are known as miners. People who approve transactions, there are different kinds of nodes, and they do different things in the blockchain. But now let's focus on miners. So this node or miners, before these transactions are being validated, they have to solve some complex mathematical puzzles. All right. It's not all right. So it's not like the person. So when I'm talking about miners now, I'm not talking about me, the person. I'm talking about the system. All right. I'm talking about the system. I'm not talking about the person behind the system. All right. So when I'm talking about miners, I'm not talking about like the person who runs the node. I'm talking about the node itself. All right. So the miner now, or miners, because there are a lot of nodes and miners. So for this transaction to be validated, this miner has to solve complex algorithms. All right, this miner has to solve complex algorithms to validate the transaction. And for him to validate this transaction, or when he validates this transaction, he gets rewarded. All right. So, and why you may ask, why are people rewarded for validating transactions? The system runs like this is because you as a sender, you can't validate your own transaction, all right? So people have to validate it. So to make sure that these transaction validations are correct, to make sure that, okay, this transaction is an authentic transaction, the validator has to stand to gain something, or the miner has to gain something from approving a transaction. That is what we call mining. This is the process of mining, all right? So when he solves that complex algorithm, validates the transaction, he gets rewarded. This is the flow, all right? This is just the flow. So people or nodes get rewarded for validating this transaction. This is another way to earn from cryptocurrency. But for talking about the proof of work consensus mechanism now, it's, for example, like Bitcoin. So it uses high computing power, all right? It needs significant energy to mine Bitcoin. That is why we don't have, it's not really common, all right? You can't use your normal laptop now and mine. It's not possible to use your normal PC now. The way I'm using a laptop to talk to us, I can't use this my laptop now to mine Bitcoin. It's not possible. All right. So it's like this is a full setup. So it's energy consuming, power consuming and stuff. So that is why you don't really have so much of it. But people do it, all right. In the Bitcoin blockchain, there's a lot of node out there because some of these people found out about this thing early enough, and people are doing it basically. So this is just explaining how the proof of work consensus mechanism works. Then pushing down to the proof of stake here. The proof of stake is as the name implies, proof of work uses work to has work to do for a validation for a transaction to be validated. But in a proof of stake, you have to stake for it to be able to validate a transaction. All right. So proof of work, you have to work. Are you catching the flow? You have to work for it to be able to validate a transaction. But in a proof of stake, you have to stake for it to be able to validate a transaction. All right. So sorry guys, give me a sec. So yeah, sorry about that. So for the proof of stake, I was saying validators are chosen based on the number of coins they are staked. They staked. So there's a minimum number of cryptocurrency. All right. There's a minimum number of cryptocurrency you have to stake for it to become a validator. This is how this particular type of consensus mechanism works. And that is where Ethereum falls under. So it is energy efficient, like you just need to stake. All right, you need some computing power. You can't really use some of your regular devices to do this thing, but it's so unlike the Bitcoin, that you have to do like a manual thing, solving the complex algorithm. So it's work. But here now it's like the Gen Z part of the crypto thing. So what you just have to do is proof of stake. So where you just have to stake a particular amount of cryptocurrency and you are good to be a validator, you are good to approve the transaction. All right. So it is not as it doesn't consume energy as the it doesn't consume energy as the what do you call it, the proof of work. All right. So this is this is how the proof of stake works. All right. So this is, like I said, these are like the two major consensus mechanisms. There are a lot of them are out there and different projects. Like now, this proof of stake now, Ethereum uses it. I think Solana too uses proof of stake. There are a lot of platform that uses the proof of stake consensus mechanism. Like I think, and there are other platforms that uses the proof of work consensus mechanism. I think this is a Bitcoin fork platform. That is Bitcoin Cash. Litecoin, I think they still use the proof of work consensus mechanism. All right. So this is just like a little highlight of the excuse me the consensus mechanism thing. So please hope we are following. I like the interaction we are getting. So hope we are following. If you are following what I'm saying and it's entering. Some of us were complaining last week that say I did bust their head. So I think I decided to do a video today so you can be seeing me and okay, it's entering. So you can be seeing me and it could be a little bit more interactive so you can see my hand gestures, my mouth, So it's just like, oh, I'm talking to you, or maybe you're watching a YouTube video. So it might not just be things you'll be hearing in your ear, so you can see me too, and we could connect more. All right. So advantages of blockchain. So one of the key or major advantages of the blockchain is that it is decentralized. All right, blockchain is decentralized. The blockchain. What do I mean by the blockchain is decentralized? It's what we've been saying every day. There is no body. There is no particular body that regulates the blockchain. Oh yeah, Lawal, this is the first time you're seeing me, apart from the pictures. Yeah. So yeah, many people on this call know me personally, so they've seen me one way or the other. So yeah. So, like I said, the blockchain is decentralized, and what do we mean by the blockchain decentralized? There is no body. There is no body. Like now, you can't say, "Oh, I control the blockchain," or you can't say, "Oh, you control the blockchain," or we can't say both of us are controlling the blockchain together. All right. So people, even though there are nodes out there, so it's not just one particular person doing it. So there are a lot of people out there contributing to make the blockchain running. All right. This is what we mean by decentralization. So different nodes are powering the blockchain. So another key advantage of the blockchain is it is transparent. All right. And this transparency now, when we're talking about transparency, we are talking about the public blockchain. All right. We're talking about the public blockchain. Like I said, some of the things we will be saying are things related to the public blockchain because these are features related to the public, like things like transparency, where you can be able to see transaction, uh, track wallet, see what's going on. And trust me, I think if we imply the use of blockchain in Nigeria, not necessarily cryptocurrency, but the blockchain in Nigeria system, I think the blockchain. I think I was watching a video either today or yesterday of there is this man, Chiemeze Chuta. He's a big guy in the crypto space in the Nigeria. He's doing an amazing work of onboarding new blockchain guys. All right. So I've like known him for a while, like since maybe 2021 or thereabout. So I've known him for quite a while now, and he was saying something. He said the blockchain is going to do a lot of good in Nigeria because Nigeria or Africa in general is a country where there is lack of trust and lack of transparency. All right, there's lack of trust and lack of transparency. And when you even look at the government sector, coming to funds allocation, you can't if or you can't the accountability is poor. The accountability is poor. The government, let's say, there is no enough accountability. So this is something the blockchain can solve when implied into the system, where these transactions are carried out in the blockchain and is visible for both the government, both users, everybody seeing what's going on. Everybody seeing how this money is being disbursed. Everybody seeing how everything is being used, how the allocation of funding is being spent, and so when you see one fund like that being, redirected, you grab, we can be like, oh, this transaction is fishy. So I think instead of the government fighting the blockchain thing, it's something they should welcome and make the good use of it. All right. So I mean, when we employ transparency or when we integrate blockchain into our system, it's going to bring a lot of checkmating the leaders, people who are these people who manage public funds. You can't just wake up and send money into an unknown account because everybody's basically watching what you are doing. So you can't just it's just like living your life on a CCTV or living in Big Brother Nigeria house that there's camera everywhere and you can't just do anything. All right. So basically that's it. So that's that on transparency. So the third thing about the blockchain is security. All right. So security with the way data are being stored across different nodes, like the way data are stored decentralized manners, this makes it quite secured. All right. The way data are stored differently, you don't store them all together. It makes it quite secured. It makes the blockchain thing quite secure because you can't hack into the system. All right. Because when you're able to, in fact, do you know why people say that the blockchain is entirely difficult or the most difficult system to penetrate, or it's almost impossible to penetrate the blockchain? And why am I saying almost is because nothing is actually impossible. All right. But so why we are saying almost impossible is because to a very great extent, it's almost difficult because of the decentralized nature because for you to be able to tamper with information on the blockchain, you have to pull down every node at the same time. All right, you have to pull down all the host servers at the same time. For it, the host servers needs to go offline at the same time for it to be able to make any tampering. And it's almost impossible to pull the host server off at the same time. All right, so it's almost impossible. You can only succeed to pull down one or maybe two, maybe three at most. And we have like, I think last time I was checking, I'm not sure. So I won't really give you a figure right now because there are a lot of servers powering the entire blockchain. Let's not even talk about different blockchain networks now. Like now the Bitcoin blockchain, there are a lot of servers powering it, the Ethereum blockchain, a lot of servers, Solana blockchain, different blockchain have servers powering it. So the blockchain is greatly secured, And because of the decentralized manner, these things are almost impossible to penetrate. So I'm seeing you guys on the call. I'm seeing Carlo, I'm seeing Oni, I'm seeing Chimereze. I saw some other persons, they disappeared. All right, you guys are welcome. So I guess you're joining quite late, so the recording will be posted on our YouTube platform so you can watch it and pick up what you missed and everything. Yeah, so I'll be talking about efficiency. All right. So efficiency now is with the blockchain, a lot of things are being reduced in some in blockchain applications. Things like speed, intermediaries, process being reduced. So like now with the blockchain, you don't have to do a lot of things. You don't have to go through a lot of verifications and here and there. So you as a user, you are interacting direct with the blockchain. So with the platform, so you don't have to. There are not a lot of intermediaries. There are not a lot of steps to go through. So it's just you and the blockchain. All right. So this is one of the another great advantage of the blockchain. So we'll be wrapping it up tonight is the limitations, because there are advantages too and there are limitations to these things. Right? And some of the limitations are scalability, high transaction volume can strain the blockchain. So when there are a lot of people trying to perform transaction on the blockchain, it can give the blockchain a downtime. That's what you call congestion. All right. Last week I was talking about something like that when I mentioned the Lana blockchain. I think somewhere in March, April, that it was congested. Right. Somewhere in March and April it was congested, that people could hardly perform a transaction that time. And funny enough, then there was this project I was handling for a project building on Solana. It was a lock. All right. It was a lock platform. So I was having issues with my clients because they were not able to perform transaction, So because of the whole congestion thing, there was a lot of failed transaction and everything. So even though we have to, I had to explain to them, was like, this is not like my fault, that it's a blockchain thing. So and then Phantom wrote it boldly that the Solana ecosystem or Solana blockchain is quite congested. So scalability is one of the major problems the blockchain faces because of its way it operates. A large volume of transaction can strain the blockchain, and it can lead to slower transaction time, that is slower transaction time or longer transaction time. So a transaction that should maybe take a minute or two will take like 5-10 minutes. All right. Then it could lead to higher fees. If you have interacted with the Ethereum blockchain, you know what I'm talking about. All right. So Ethereum blockchain is a blockchain that can charge you $50 for a $10 transaction. It did happen. All right. So it did happen. So this is some of the limitations that the blockchain faces, and the government issues, the energy consumption. This is like when you're talking about the proof of work consensus mechanism. All right. So, and you know, the privacy needs too, because yeah, when you're talking about privacy, it's just like um because of the way the public blockchain is, you can monitor anybody's transaction, like anybody. So it's easier to stalk people's wallets. So once you and to get people's wallet address is one of the easiest things to do, because all you just need to go is maybe go on chain, maybe check out a token that is maybe a token that is pumping. If you learn about the gene trading, there's what you call wallet tracking. All right, so wallet tracking is where you go check out people who made good profits from a particular project, and you track their wallets to see, like you check, okay, they've consistently made profits, good profits from. So that means some projects you are monitoring when they are buying and when they are selling. So once they buy, you buy. Once they sell, you sell, because they have an information you basically don't have. All right. So you can be tracking like 2 to 3, and like these are people that are going with small money and make high profit. So if there is that consistency, so you can be tracking them, monitor what they are doing, monitor the kind of project they are investing in, and it's a thing in the blockchain. But it bridges privacy, because I might not want to. And some people, that's why there are guys in crypto, once they are done trading with this particular fund, like this particular wallet, they will transfer to another wallet so that people won't be able to track their wallet, all right, and see what they are doing. So they will just transfer the funds to another wallet, and continue. So they just keep changing wallets, and like that. So they might not be using one wallet for a long time. So this is one of the disadvantages of public blockchain. It has issues with privacy, all right. Even though, yes, in some part of the blockchain where you have the private blockchain and privacy could be applied, but what's public is public and everything. So which is something like a challenge. Yeah. So this is where I'll be stopping tonight. So next week we'll be going into cryptocurrencies, and we'll talk about money. All right. So we've been talking about the technology, the blockchain, we're talking about the technical part of it, but next we'll be talking about cryptocurrency, we're talking about things around the evolution of money, and very interesting thing. I'll be telling you guys a lot of stories. So we're talking about evolution of money, then getting to cryptocurrency, still take us through the basics. So if you still find anything confusing with cryptocurrency, you shouldn't miss next week. All right, you shouldn't miss next week. Yeah. So before I wrap it, does anybody have any question? Does anybody have any question?